to another episode of Salt Air. I am your host, Janae Andrus, and the Salt Community Manager. So we're excited to have you here. I'm not here alone. I'm here with the one, the only Tom Hatch, creator of Salt. What's up, Tom?
Hey!
Glad you're here. We couldn't do this without you because you are the salt of salt. Can we say that? Salt of the earth, salt of salt.
I'm a very salty fellow.
That is true. I won't argue with you there. So I put my glasses on because it's a vocab episode and I'm excited. Are you ready to take some vocab terms? So we've done a couple of these so far. We've done, basically we just take a bunch of words that are very related to salt, because here at Salt Air, we get granular on salt. And if you want to keep getting granular with us, by the way, don't forget to subscribe because you won't want to miss our vocab lessons. I love them. Basically, every industry, right, has their own industry terms. And in salt, we are no different, but we don't want to become inaccessible because of our terms. So we're going to catch you up. So Tom, you ready to just rapid fire some vocab words?
Yeah, hit me.
All right. Speaking of hit you, targets. Start with targets.
So targets, one of the primary things that salt is used for is remote execution. A lot of people don't realize, looking from the outside in, that salt is primarily a high-speed remote execution and command and control system. And the way that we target systems is much more robust than other command and control systems that are out there. And so I'm very, very proud of targets. And we've worked very hard to be able to do what we can do with targets. A target is basically a definition of who's going to execute the command. And targets are flexible because we can target groups of systems based on name, network information, system information. So it's very easy to do things like target every Linux machine, or target even every machine that's got a certain CPU in it if it was so necessary, or every machine that's got a specific BIOS version. I mean, so you can get extremely granular with target selection. And over the years, it's been one of our goals ongoing to make sure that the target that you select can solve virtually any problem on the fly there.
So how does target relate to endpoint? Because endpoint's, obviously what that is. And so an endpoint can be a target, but that doesn't mean a target's always an endpoint. Is that right?
Right. A target is going to say that we're going to dynamically determine what collection of endpoints are going to execute this command. So it makes it really easy to say, hey, I need to target all the Linux systems to find something out about them, or I need to change the root password on all the web servers, or I need to update the software on this specific database cluster. Targets makes that really, really, really easy inside of Salt.
Oh, that makes a ton of sense. Okay. This next one makes me hungry. Salt thin.
So Salt thin. Salt thin is a little system that a user doesn't actually have to interact with very often. But the Salt thin system is a system that takes your installation of Salt and then bundles up all of the Python components in a little portable tarball, so that portable tarball can then be sent over the wire, typically over SSH, so that it can be executed on a remote system's Python. And so it creates a thin Salt. Again, that only requires that Python is installed on the remote system. Salt thin is the thing that we use for Salt SSH. And so when you run Salt SSH, you need Python installed on the remote system for it to work. But we're going to be able to take the existing Python components that are on the install that you're using from Salt SSH and transfer those over to the remote system, which means that you're able to have version consistency across Salt SSH commands. And it also makes it very quick because we're able to cache the Salt thin instance on remote systems as well, which means that subsequent Salt SSH calls are significantly faster than the first Salt SSH call. And this is also one of the things that we do that help us make Salt SSH so much faster than any other remote execution system that uses SSH. There's quite a few out there that do.
That's awesome. Okay. Top file.
So top file, when we're executing states, we're using config management. The top file is one of the ways in which we're able to determine what's going to be executed on those systems. One of the things that I wanted to make sure we were able to do with Salt is that when you spin up a new system and have Salt installed, that new system should not need any configuration added to it post the installation of Salt. Once Salt is installed and connected, that system should be done and ready to go. A top file allows us to determine which systems are going to receive which components and which configuration management routines. And the top file does that by using targets. This also means that there's really no other config management system that's able to organize what machines are going to be receiving what config management routines, because nobody else has the flexibility that we have instead of targets, because they're not built for highly flexible command and control as well. And so that targeting system is built into top file. So in a nutshell, the top file basically allows you to say, this target is going to run this set of config management routines. The top file can also be used to have multiple overlays. So you can say that I've got a base target that has so many systems that are going to be hit, and then I've got more specific targets for more granular systems. So the top file gives you a significant level of flexibility.
It was an absolute accident that targets came before top file, and it just all worked out, right? And
keep going. Maybe we'll have a few more happy accidents.
Right.
So it just picks these terms at random, basically. We've got just a couple of big lists.
It's more fun when I pretend I don't know what's going on. I'm not an evil mastermind. Okay, so I'm actually going to throw the next 3 at you, because when you say them all together, it sounds like a Dr. Seuss novel. Well, not novel. He didn't write novels, but a Dr. Seuss book. We have high state, low state, high data, but not low data. It's low chunks, right? Even though that will really make me lose my salt bin appetite.
Okay, so you said high data, low state, and high state?
And high state, that's right.
Okay, so this is diving into the compiler. And so this is information that most Salt users never need to worry about. But this is how the compiler works.
Yeah, so don't tune out, because you're just going to get smarter.
Yeah, so when you define Salt states, generally in YAML, those get rendered down to a data structure, which is basically a JSON, some JSON data. And that is a high state. Okay, a high state is the first representation of that data structure. And then we refine the high state into high data, which then we pass into the compiler. And then the compiler translates the high data into what we call low data. A low data is a list of low chunks, and each low chunk is an execution routine inside of the config management engine's runtime. And so what we end up with there is that the high data, the high state is that more human readable representation. The high data is our cleaned up, ready to compile data set. The low state is a list of chunks, and each chunk represents an execution. And then that is where we process, during the runtime, is where we process requisites. And so the low state is completely deterministic. Salt always runs in the same order every time it's executed. Because if it's not deterministic, then that's just bad computer science, and I'd fire those people. Yeah, not okay. Don't make non-deterministic software. It's not cool, man.
Don't do it.
Determinism. Even if something is declarative, then it still needs to be deterministic in the manner in which it's executed. And so then the low state is the order of evaluation. So it's always the order in which things are evaluated. And then what we end up with is that we need to be able to have the requisites resolve things. And so the resolution of the requisites is what changes the order, but there's a finite order of requisite resolution, which means that, again, we maintain determinism while still executing in an imperative fashion to achieve a purely reliable declarative state.
And that is time. So thank you for running through these vocab terms with me and the Dr. Seuss high state, low state, high data. That was fantastic. So we reviewed targets, salt bin, top file, high state, low state, high data. And now you're just a little bit smarter. Thanks for getting granular on salt with us today, and we will catch you next time on Salt Air.